Good morning, class. Today we are now on the second quarter of our subject, General Chemistry 2, and we are now on the topic, Stoichiometric calculations for reactions in solution, or what we call stoichiometry. So, I have a question. What is the chemist's favorite plant? So it is stoichiometry. So it is a joke lang. So when we say stoichiometry, stoichio means if we dissect this word into two between stoichio and metry. Stoichio is a Greek word for the element, and metry is what we call the measurement, the Greek word for measurement. So stoichio is a Greek word for element, and metry is for measurement. So it is the measurements of the elements in a certain reactions. Stoichiometry is about measuring the amounts of the elements and compounds involved in a reaction. A quantitative study of reactants and products in chemical reaction is also what we call stoichiometry. Consider the chemical equations given. We have 4 moles of NH3 plus 5 moles of oxygen yield the products 6 moles of water and 4 moles of NO. So as you can see, there are several numbers involved. We have 4, 5, 6, and 4. So what do they all mean? So stoichiometry is like making cookies. Who among you always or does who among you have already baked a cookies? So when you bake a cookies, there are certain measurements that you are going to use, because if we will bake, we need some ingredients with certain ratios. So stoichiometry is also like that. So we have different ingredients, or we have different measurements of a certain reactants in a chemical reaction to form a product. So like for example, in making cookies, we have this recipe: one 1 cup of butter plus 1 cup of sugar plus 2 egg yolks plus 1/4 cup vegetable oil plus 1/2 cup of cocoa powder plus 2 tablespoons of vanilla and 2 and 1/4 cup of flour plus 1/4 tablespoon of salt plus 1 cup chocolate powder plus 4 of semi-sweet chocolate and 2 tablespoons of cream will yield a 32 mud puddle cookies. So if you have these ingredients with a certain measurements given and combined all of this, it will yield to 32 pieces of cookies. But if we try to look at, there are some ratios that we were going to use in order to yield, like for example, 32 pieces of cookies. Now, if you will double the number of the cookies that will be made, you would also double the different measurements of the ingredients. Like for example, so if we want to make 32 pieces of cookies, you need 1 cup of butter. But if you want to double it from 32 to 64 pieces, you need how many cups of butter? You need to double the butter. So we have 2 cups of butter. And if we double the 2 cups of butter, we need also to double the eggs. How many eggs do we use in this? So if we want to double the eggs, we can get the 64 cookies. So 2 egg yolks, double it, will become 4 egg yolks. Same also with the different ingredients in making these cookies. So that's is also how the different compounds in a given reaction is being measured. So making cookies is just like also making chemicals. So in the laboratory, we make chemicals by using stoichiometric calculations. So if we want some, as you can see, there are some examples in these pictures. We have different chemicals here, products, chemical products, like this one. It's a shampoo. So in making this shampoo, all the ingredients needed must be balanced in a particular stoichiometric calculations. So for example, we have here the given chemical reaction. By the way, class, in order for you to understand well on the stoichiometric calculations for reactions in solution, you need to master first balancing chemical equations, which is already taken last year in your General Chemistry 1. So you need to master first the balancing chemical equation for you to understand well on the topic stoichiometry. So we have here a given chemical reaction. So this is a chemical equation in a given chemical reaction. So you can observe that there are numbers and there are also formulas in each compound. These are the observable things that you can see in a chemical equation. So if we dissect it one by one in each compound, we have NH3, which is one atom composed of one atom of nitrogen and 3 atoms of hydrogen atoms. And we have oxygen, which is composed of 2 oxygen atoms. And we have water, H2O, which is composed of 2 atoms of hydrogen and 1 oxygen atom. And we have NO, 1 atom of nitrogen and 1 atom of oxygen. So these are the different elements and compounds which can be seen in our chemical equation. So as you can notice, there are some numbers here on the left side of that compounds or elements. These numbers represent the number of moles, which is also the measurements being used in calculating stoichiometric reactions. So we have here 4 moles of NH3 added with 5 moles of oxygen. It will produce 6 moles of water and 4 moles of NO. So we have now the ratio 4:5 will produce 6:4 products. Okay? So in calculating the reactions in the solution using stoichiometry, you need to have your periodic table. We will base the weight or the atomic weight of each elements and compounds in the periodic table. Let's say, for example, NH3. NH3 has 17.0 grams per mole. This is the standard measurement. And we have oxygen, 32.0 grams per mole, and hydrogen, which is 18.0 grams per mole, and NO, 30.0 grams per mole. To find the molar mass of a chemical formula, you just add the atomic masses of the elements forming the compound. You use the periodic table to determine the atomic mass of individual elements. So again, to find the molar mass of a compound, you just need to know the atomic weight of each element and multiply it with the subscript. Like for example, H3. So N is only 1. H3, the atomic weight of H is 1.008. So times 3. All in all, you just have to add. Then we have 17.0 grams per mole. So that is the molar masses of the elements in a given reaction here. So recall that chemical formulas are balanced with coefficients. So first we need to make sure that our reactions in the chemical equations is balanced. So as you can see, we have here 4 nitrogen and 12 hydrogen in the reactant side. And we have here in the reactant sides, we have 12 hydrogen, and in the products also we have 12 hydrogen. Oxygen here in our reactant is 10, also in our products we have also 4 plus 6 equals 10, so it is balanced. And what about H2O? We have 12 hydrogen plus 2, it is also balanced. What about NO? We have 4 nitrogen plus 4 oxygen. So 4 nitrogen, 4 nitrogen. So all of the elements here are balanced. It is very important that our chemical equation is balanced. So with stoichiometry, we find out that there are this ratio that we can find. So we have 4:5 is to 6 is to 4. So it means that if we add 4 moles of NH3 plus 5 moles of oxygen, we can yield or produce 6 moles of water and 4 moles of NO. So this is what we call the mole ratio. So 4:5:6:4 can mean either 4 molecules of NH3 react with 5 molecules of oxygen to produce 6 molecules of water and 4 molecules of NO. Or 4 moles of NH3 react with 5 moles of O2 to produce 6 moles of H2O and 4 moles of NO. So we have here the stoichiometric example. So always remember that the moles of the reactants is equal to the moles of the products. Let's take a look at this equation. We have here a reaction that takes place between lithium and water. So we have here a lithium, which is solid, reacts with water, which is liquid, to produce lithium oxide, which is an aqueous solution, plus H2, which is a hydrogen gas. So we have here a question. How many moles of H2 will be formed if 6.23 moles of lithium combined with water? So how many moles of H2? As you can see, H2 is in the product. So, ilan yung H2 na magagawa natin kung meron tayong 6.23 moles of lithium combined with water. So, ilang H2, ulitin ko, ilang H2 ang magagawa kung meron tayong 6.23 moles of lithium which is combined with water. So, what is the answer? First, we need to check if our equation is balanced. Is our equation balanced or not? We have 2Li, 2Li, 4O2, 4. Okay, our equation is balanced. So, the second step is convert the required amount to moles. So, the given is 623 moles of lithium. Do not need this step for this. Okay. Number 3, the third step rather, is find the mole ratio using the coefficients. Okay? Use the coefficient. Coefficient is the number behind an element. Yung mga number na nakikita nyo dito sa katabi ng element is what we call coefficients. So there are two moles of Li. 2 moles of Li is equal to 1 mole of H2. Kung meron kang dalawang moles ng lithium, makakagawa ka ng 1 mole ng H2. Yan yung ibig sabihin nun. So since the given is 6.23 mole of Li, then we use this as our conversion factor. So this relationship, we will use this to convert 6.23, which is given, to the number of moles of H2. Kasi yung hinahanap natin is ilang H2, ilang moles of H2 ang magagawa kung meron kang 6.23 mole. So, kada dalawang lithium or moles of lithium, makakagawa ka ng isa. So, kung kada dalawa isa, kung 6 ang given, 6.23 ang given, so malamang kung titingnan mo lang sa kanyang chemical reaction, possible na answer is it is something 3 point something kung 6 lang ang given. But it is 6.23 moles, so we have to convert this. Okay? Convert this. So, 6.23 mole of lithium times 1 mole of H2. Bakit nandito sa taas yung H2? Ito kasi yung hinahanap natin. Lahat ng hinahanap, nasa taas. Lahat ng ika-cancel, dapat nasa baba. So, kailangan makancel itong mole of lithium. So, we need this relationship. 2 moles of lithium is equal to 1 mole of H2. So, the answer is 3.12 mole of H2. So, kung meron kang 6.23 mole of lithium, makakagawa ka ng 3.12 mole of H2. So, the last step is to convert the desired unit. So, the answer is 3.12 mole of H2. Alright, another examples. So how many moles of water are produced if 2 moles of O2 are used? So we have here still an equation used in example number 1, but the difference is we're looking for the moles of water that are produced if 2 moles of O2 are used. So since the reaction given, we have 4NH3 plus 5O2 will produce 6 water and 4NO. So since in every 5 moles of oxygen, we can produce 6 moles of water, the given is 2.0 moles. So what we are going to do is convert, use first this relationship. In every 5 moles of O2, there are 6 moles of water. Use this as our basis for converting the desired unit. So how many moles of water are produced if 2 moles of O2 are used? So we have here the given, which is 2.0 mole of oxygen. In every 2 moles of oxygen, there are 6 moles of water, and in every 5 moles of O2, rather, there will be 6 moles of water. So convert this, we can get 2.40 mole of water. So this is now the answer of this question. How many moles of water are produced if 2 moles of O2 are used? So notice that a correctly balanced equation is essential to get the right answer. So if the equation is not balanced, you need to balance it first before you can get the desired unit that you are asked to. So another example is how many moles of NO are produced in the reaction if 15 mole of H2O are produced. So we can get also our answer by basing it with this equation. So how do we do that? So the given 15 mole of water. So in every 4 moles of NO, there are how many moles of water? We have 6 moles of water. So to cancel water, to derive at our desired unit for moles of NO, so we have 10 mole of NO. So this is how stoichiometry is being used for calculating some reactions in a solution. So that's all for this morning. I hope you learned something, and we will see again in another video lesson like this. Thank you very much for listening, and have a safe and happy learning to all of you.